like this, that's all the maths.
Okay, looking at question 4, it says 30 learners were asked to answer a question in mathematics. The time taken in minutes to answer the question correctly is shown in the frequency table below. As you can see, they've given us a frequency table. Let me just jot it down. The time interval from t to 3, 5 and 5. Okay, and in total these are 30, as they tell us. There are 30 learners. And then, moving on to the question 4.1, it says, construct a cumulative frequency table for the data. Okay, so we'll just do it on this table already. So now you're just constructing your cumulative frequency table. You just need to put another column for your cumulative frequency. Okay, and remember with cumulative frequency, you start off with the same number that they have on top, which is 3. Then from there, you continue adding the next number. So 3 plus 6 will be 9. So your next number here will be 9. Then 9 plus 7, 16. 16 plus 8, 4. 24 plus 5, 29. Then 29 plus 1. And always, as a check, your last number here should always indicate the total frequency you're working with. Okay, so in general that's question 4.1. Then 4.2 says, draw a cumulative frequency graph of the above data on the grid provided on diagram sheet 1. Okay, so in your papers you would check in you would draw the diagram in your diagram sheet as given in your paper, but let's maybe just do a rough representation of what they want. Okay, let's see what interval we can work with. We'll work with 0 up to maximum is 35. Is 30, so we'll work up to 35. Okay, and our intervals are increasing by 3. So let us work with intervals of 3. Okay, then roughly we'd have that. Okay, so this will be our axis, our scale that we'll be working with. Then you're simply plotting your cumulative frequency versus your time in minutes. So in other words, it's this interval versus that. And with our intervals, we always plot the points we have on our cumulative table with these points. The points at the end, 3, 5, 7, 9, 11, and 13. Okay, so we'll start off here when, firstly, the interval starts at 1. So at 1, it's 0. So that'll be our first point. And then our next point is 3. So at 3, it's also 3. Roughly it will be somewhere there. Then 5 and 9. 5 and 9. Next point, 7 and 16. Next point, 9 and 24. Okay, the next point is 11, 29, then last point 13 and 30. Then 13 and 30. Okay, so roughly that's how it will look like. Then if we try join the points, it will level out like that. Okay, so that should be your answer for question 4.2. Okay, any questions? It's pretty straightforward, yeah? Okay. So after that, let's just make it a solid line to complete it. Okay, and lastly, let's look at the last question, 4.3. It says, if a learner answers the question correctly in less than 4 minutes, then he or she is classified as a gifted learner. Estimate the percentage of gifted learners in this group. Okay, so we're looking at everything which is less than 4 minutes. These are our minutes. You come to 4. 4 is roughly there. Then, if we move up, it's roughly there, you see. Then we would work with, only working with the estimates that we have. So, one of those estimates, or rather the interval where we start off from, is at 5. So we'll estimate at 5, because the question is estimate. So we'll take the whole number 5 from our cumulative frequency as the unit we're going to use for the calculation. And it's 5 out of a total of 30. So a percentage of that is just 5 out of 30 times 100. So 5 students roughly got less than 4 minutes. And then it's 5 out of the 30 students times 100. And if you check that, it should give you 16.67%. Okay. And that will be your question 4.3. Any question? Okay. So that's question 4. Moving on to the next question, question 5. The diagram below, PQRS is a rectangle with vertices for P, -4, 0, for Q, 4 and A, for R, 6 and 0, and for S, and for R. And they say S and Q lie in the first quadrant. Okay, then the questions are based on what they've given us in the diagram. So 5.1 says, show that A is equal to 4. I want you to show that A is equal to 4. Okay, looking at where A is only visible at the point Q. And that point is 4A. The only way I'd rate to go about doing this would be to use your knowledge about straight lines. They've given you the point P as -4, 0, and they've also given you the point R as 6 and 0. Both those points have a link to the point Q. So it's like you can now use, and you can see they link up at point Q. You can use 2 lines to solve simultaneously. In other words, you find the line PQ and you find the line QR. Then you solve those 2 simultaneously to solve for your unknown A. Okay. Let's go about doing that, or even easier would be to use your gradients. That would be way quicker. In other words, you've got M PQ, which is a gradient for the line PQ. And we know that the equation is y2 minus y1 over x2 minus x1. y2, we'll consider point Q, is A minus, for point P, that would be 0, over x2, which is 4, minus x1, -4. All in all, this would be A over 4 plus 4 is 8. That is MPQ, the gradient for PQ. Let's also now try to find the gradient for QR. We'll call that MQR. Once again, it's y2 minus y1 over x2 minus x1. Let's consider y2 from Q. That would be A minus 0 over 4 minus 6. And this is A over -2. Correct me if I'm wrong, but what do we know about 2 lines, about the gradients of 2 lines? What's the relationship between the 2? If that's M1 and that's M2, the relationship is that M1 times M2 is equal to -1. So those two lines are perpendicular. So let's use that knowledge then. So we know that MPQ times MQR is equal to -1. What's MPQ? A over 8. What's MQR? Negative A over 2 is equal to -1. We multiply this out. This will become negative A squared over 16 is equal to -1. Then they're both negative. You can convert them to become positive. In other words, you'll be left with A squared over 16 is equal to 1. Then you multiply out by 16. Then eventually you have A squared is equal to 16. Then obviously to solve for A, you're going to say the square root of 16, which is 4. So let's write it here. Therefore, A should equal 4. It could be plus or minus 4, but then as you can see, A is in a positive quadrant. So we just go with 4. Okay, any questions? Okay, so question 5.2, it reads, determine the equation of the straight line passing through the points S and R in the form y is equal to mx plus c. Okay, as you saw, we had the point P and the point Q on our diagram. And P has coordinates -4 and 0. Q has coordinates 4. And we found what A was. It was 4. Okay, then they want us to find the equation of the straight line, which is parallel to the line PQ. And that is, they want us to find the equation of SR. Okay, there's a reason why I've drawn them like this. What do parallel lines share? The same gradient. We do not know what the point S is, but we know what the point R is. We need this line, PQ, in order to calculate the gradient. So that's where we start. So M of PQ, which is equal to the M of SR, because they're parallel, we'll follow the equation y2 minus y1 over x2 minus x1. So it will be 4 minus 0 over 4 minus 4, which gives you 4 over 4 minus 4 is 8. So our gradient there is a half. Okay. So in other words, the gradient of this line is a half. Then equation of a straight line is y minus y1 is equal to mx minus x1. Or you could use y is equal to mx plus c. But let us use this since we've got a point there, and we know what m is. So we'll use this point. Y1 will be 0, m is a half, x minus x1 is 6. Then from this, it's pretty much simplified. This becomes y is equal to a half x minus 6 times a half, which is 3. And that's your answer for question 5.2. As we've written it the way they want. Y is equal to mx plus c. Okay, any question? Okay, so moving on. Question 5.3. It says calculate the coordinates of S. Okay, so we're trying to get the coordinates of S. In other words, they want the X and Y coordinate. Okay, in order for us to do that, we can use the logic which I was referring to in question 5.1. You've got the line PS, and you've also got the line SR. We've calculated what SR is. If we knew what PS was, we'd then just solve them simultaneously to solve for S. Okay, so the first thing we need to do is try find what PS is. Once again, we've got 2 points that we know. We've got the point QR, right? So we can use the gradient of that line in order to find the gradient of PS. Already we've calculated our gradient. We found that the gradient of MPQ was a half. Since QR is perpendicular, we'll solve for its gradient using the same equation we used earlier. So it's MPQ times MQR should equal -1. MPQ is a half times MQR should equal -1. Therefore, MQR will equal -2. Okay. So MQR is -2, and this should equal to also the gradient of MPS. Then once again, we use this formula, y minus y1 is equal to m x minus x1. We'll use the point P since it's on that same line. So it becomes y minus, the y1 is 0, is equal to m, -2, x minus x1, which is -4. Then we simplify this. This will become y is equal to -2x, -2 times, this becomes +4, -8. So all in all, we've got y is equal to -2x minus 8. This is for the line PS. And earlier, we calculated what our line SR was, and we got y is equal to half x minus 3. This was for your SR. So now we're going to use our knowledge of simultaneous equations to solve for the two unknowns to find out where they meet, where they intersect. In other words, we're going to solve for the coordinates of S. So in order to do that, we all know, we'll name that one 1, and we'll name this one 2. Okay, then from 1, and that equation is y is equal to -2x minus 8 into 2, we'll substitute for the y. So now it becomes y becomes -2x minus 8 is equal to a half x minus 3. Okay, then we'll solve for x now. This will simply become, if we multiply out by the 2, we'll have -4x minus 16 is equal to x minus 6. Bring this 4x this side, it become x plus 4x. Bring the -6 this side, it becomes 6 minus 16. This is -10. And that will be 5x. Therefore, if you divide both sides by 5, you'll get x is equal to -2. Then lastly, y should equal, if we substitute into that equation, it's -2 times -2 minus 8. This will become 4. 4 minus 8, which is -4. Therefore, S is the point -2, -4. Okay, any questions? Okay, so that's question 5.3 done. So question 5.4 says, calculate the length of PR. As you can see, PR lies on the x-axis, right? And they've given this point as -4, 0, and this point as 6, 0. Okay, there are two methods to doing this, either using the distance formula, or since they both lie on a straight line on the x-axis, this is just a normal number line if you can choose to view it that way. In other words, the space from there to there is the distance. So you're moving from -4 up to 6. So -4 up to 6. Let's try see what that distance is. So this distance is simply 4. Okay, and that distance is simply 6. So it's the same as saying, if we were to subtract them and say 6 minus the minimum, which would be 6 minus 4, which is 6 plus 4, which is 10. Okay. Or some students prefer the distance formula. You could go ahead and use the distance formula. It will still give you the same answer. Okay, so that's question 5.4. Moving on to question 5.5. It says, determine the equation of the circle that has diameter PR and give the equation of the circle in the form x minus a plus y minus b all squared is equal to r squared. So that formula is x minus a all squared plus y minus b all squared is equal to r squared. We all know that for our circle, these 2 points are the center and r is your radius. We already know the length of our diameter, it's 10. So r is simply, it's 10 divided by 2. Radius, okay, so that would be 5. Then the center, can you see, if you move this, it should move 5 points to the middle for you to get to the center of PR. In other words, or even subtract 5 from this end. That center will be somewhere there. So 6 minus 5 would be 1. So that point there is 1, 0, since it's on the x-axis. So that's what we're going to substitute into our equation. So this will become x minus 1 whole squared plus y minus 0 whole squared is equal to 5 squared. Then this we can leave as x minus y squared minus 1 whole squared plus y squared is equal to 25. Okay, so that will be your question 5.5. And let's look at question 5.6. It says, show that Q is a point on the circle in question 5.5. Okay, this is straightforward. In order for you to show that Q is a point on the circle, you just simply substitute for the value of x. Then y should equal to the value that Q has for y. So since at point Q, that coordinate is 4, 4, let us substitute x into the equation of the circle. That will become 4 minus 1 whole squared plus y squared is equal to 25. 4 minus 1 is 3, 3 squared is 9, plus y squared is equal to 25. Then we'll have y squared is equal to 25 minus 9, which is 16. Therefore, the square root of 16 is 4. Therefore, this concludes that the point Q actually does lie on the circle. Okay, so that will be your question 5.6. Moving on to the last question of question 5, it says, rectangle PQRS undergoes the transformation xy, linking it to x plus k and y plus l, where k and l are numbers. What is the minimum value of k plus l so that the image of PQRS lies in the first quadrant? Okay, so if you look at your paper, rather we can use our diagram here. We've got the points, we calculated what our point S was, and it was minus 2, minus 4. And this point P is negative 4, 0. Okay. Then let's try and see what is happening here by the criteria that they want us to solve this equation. Okay, so they're saying the rectangle undergoes that transformation, which is xy to x plus k, y plus l. And they're saying that k and l are just numbers. And they're asking what is the minimum value of k plus l, so that the image PQ, the Q was here, RS, shifts into the first quadrant. In other words, we need to move this into the first quadrant. First of all, this is in the third quadrant. We need to get it out of the negative domain. So in order for this point, in other words, if we put, let's take this point negative 2, 4. In order for this to move out of the negative quadrant, we're trying to get it to the first quadrant, which is on the positive side this will simply become, since it's negative 4, we have to shift it 4 units up. That would be the minimum value. If it's 5, it will become 1, but we just want the minimum. So negative 4 plus 4. So this should become negative 4 plus 4. In other words, L should be 4. Then let's look at that point. It's also in the negative quadrant. We don't really care much about R because it's already in the first quadrant. We're looking at now point P. We're trying to shift it into the first quadrant. So in order for this to move into the first quadrant, you also need to add 4. Do you see that? So that it becomes the point 0 for x, which is the minimum value for it to get into the first quadrant. So that point is also negative 4 plus 4. In other words, k should equal to 4 and L should equal to 4 in order for our diagram, our graph rather, to move into the first quadrant. Okay, then the question is, what's the minimum value of k plus L? So k plus L is 4 plus 4. And that minimum value for our graph to be able to move into the first quadrant is 8. Okay, and that will be question 5 done.